All right, let's start. So,
Little thing.
we're going to look at some normal distribution solving practical problem. Trying to understand the questions and then answer. All right, worded problems. Before that, I need to show you what is quantiles and percentile, the difference between quantile and percentile in the context of the normal distribution, and then be able to solve problems called calculate probabilities, simple and complex. So the quantile of the data, quartiles, not quantile, quartiles of the data, which is quarter, we split it into 25%. So it's a set of data, if it is quartiles, with the R, quartiles, we split into 4 equal parts, where we've got Q1, which is 25th percentile, median, the 50th percentile, and Q3, the 70th percentile. So introducing a new word, quantiles. Instead of R is N, quantiles.
Quantum.
Quantiles is dividing the data into 100 equal parts. So if we say that 70% of the score of a normal distributed continuous random variable are below 55, the 55 is 0.7 quantile. So quantile is just 0.7 and percentile is 70th percentile. That's the difference. All right? So, therefore, 25 percentile is 0.25 quantile.
Oh, quantile, okay, yeah.
50th percentile is 0.5 quantile, and 75 percentile is 0.75.
But we don't
quantile.
know.
Sorry?
The quantiles just depend on the standard deviation and the mean, right?
The quantile is dividing equally to 100%, and yes, definitely depends on that.
Yeah.
All right. So if it is 55, 70%, that is the 0.7 quantile or 70th percentile.
Yeah.
All right. So can you determine the following using for normal distribution with a mean of 20 and standard deviation of 3? I mean, the first one is pretty straightforward. 0.5 quantile is actually the median. Median, you don't even have to, you know there is standard deviation, you don't even have to calculate. Reading from the graph, you straight away know that it's 20. All right? Median, the mode, and mean is exactly the same for the normal distribution. So you could try the 0.82 quantile using your calculator. The area is 0.82. So you know the probability of x less than k is 0.2. So quantile is the same as percentile in a way. Quantile is just in decimal form, and percentile is 100 of the quantile.
Inverse number.
You should know how to use your class pad. Grab your class pad out and work it out, please. Oh, you can't do this one. No. Yeah, this is the class pad. Pretty straightforward. Use your class pad. You know your area. The area is minus infinity. This is left tail. Minus infinity to k and 0.82. Now, by the way, you can see that if you're looking at quantile, it's always left tail, or percentile is always left tail. All right? It's always left tail.
Because you had a formula yesterday.
No, why are you integrating, bro? Inverse, mate. Inverse.
Yeah, I did get the right answer though.
You should
Inverse
actually
norm city, yeah.
Left tail.
Left tail, yeah.
Left
You
tail?
should get the right answer.
So,
0.82.
On a your means.
Oh, yeah.
yes, you got to. Now, 20 and 3. Just remember, you have to input if you follow with your class pad. It's the standard deviation first before your mean. Like I say, I've done so many mistakes in terms of this sort of calculation. I input the mean first and then the standard deviation. So be careful with your class pad.
So,
Alright,
you
yeah.
get the same answer if you did right tail 1 minus.
Yeah, you get the same answer, right tail 1 minus, yes.
1 minus y.
Yep, yeah. So both the two areas end up to be 1. So it's alright. Alright, straightforward. Oh. I forgot to animate this, but doesn't matter. So the random variable x is normally distributed with a mean of 20 and a variance
Right,
of 4.
Axel, you're
Alright,
testing.
now here,
Wait, who you say?
read the question carefully. Variance of 4, so you need to do a square root to get your standard deviation, alright?
Yeah.
The random variable y is such that y equals 3x plus y. So determine the lower quartile, median, and upper quartile of y. Alright? I've given you the answer.
Yeah.
In this
it's
situation,
not sure.
what I would do is, I will always write out my x first. So CRVX is normally distributed with a mean of 20 and a standard deviation of 2. Remember, if they give you variance, square root. Take the square root of that.
Yep.
Lower quantile is Q1, upper quantile, not quantile, quartile. Lower quartile is Q1 and upper quartile is Q3, not Q2. Q3. Alright, median is Q2. Now, so, the main thing for you to remember, you must be able to use this transformation.
Yeah.
You can see that you should remember that when we transform the mean, you got to use 3x plus 5. Alright, you move the whole thing across.
Will we ever be asked to try? How do you find the standard deviation?
You just multiply it by 3. So the random variable is 3x.
Alright, so you know therefore the mean of y is 65. And then for standard deviation, it's just multiply by the standard deviation of x, that's it.
So,
Yeah?
do we need to know how to transform like the median of
Sorry?
like if there's like y equals 3x plus 5,
Yep.
and like do we need to change the median of it?
For a normal distribution, median is the same as mean. It's the same as mode.
Oh yeah,
Yeah, so it's the same. Yeah, in this case, it is the same.
Yes, good.
Alright, so therefore you can work out the lower quartile, which is using y is less than q1 is 0.25, so therefore lower quartile is 16.95. Now generally,
Celebration.
in this sort of situation, yeah, I'll give 2 decimal places.
lower quartile 60.
I'll give you answer. Probability, I always give you my answer in 4 decimal places,
Oh, you don't
unless
listen.
specifically asked for 2. Alright? 4 decimal places, especially if you use decimal, 0 point whatever. And then if you write in percentages, will be 2 decimal places. But decimal, always 4 decimal places.
Sir, but you didn't do 4.
Mhm.
Oh, no, never mind.
Alright? So happy with it? So you know that median is the mean, it's the same as mean, and it's the same as for the normal distribution. Alright, now we're going to go into, of course I've got to write down this one as well, definitely.
Yeah.
Definitely, that has to be written down. Always write down your distribution. So now, if you solve practical problems, you can use your normal CDF and inverse normal CDF.
Ink. Ink.
Not ink. It's inverse
That's not a
INV.
thing.
Inverse normal CDS from class S to solve this sort of problems. It's my typing skills, alright? Okay. Now, very important. The next statement is very important. You must always start by defining your random variables, stating the type of distribution and its relevant parameters. So you have to, because you would get questions which would involve normal distribution and binomial distribution, that sort of stuff. All right. So always state the type of distribution and the relevant parameters. So for normal distribution is x is normally distributed with a mean and standard deviation. All right. Now example 3. Again, I've given you the answer. Read the question, please. Let's read the question.
Ooh, I can't read the question.
IQ test.
I can't read the question.
25 out of 25.
Well, you got 25 in your IQ test. Ish. That's not possible, bro.
Apparently vegetative state is like IQ of 7 or something like that.
How is it 7? They can't do anything.
I don't know, but that's what I
Alright.
saw.
So, now if you read this question carefully, the time for Mark getting out of bed until his arrival to school is normally distributed with a mean of 55 minutes and a standard deviation of 5 minutes. So if you really want to draw it, it should look something like this. This is 55, 60, 65, 70, 50, 45, 40. So you know that you've got something like this. One standard deviation away is 60 if he's later, or earlier is 50, and so on and so forth. All right, now he arrived to school. His arrival to school is considered to be late if it occurs after 9:10 a.m. All right. So Mark got out of bed at 8:08 a.m. this morning. What was the probability he arrives late this morning? So you need to think about from 8:08 to 9:10. How many minutes are there?
62.
62. So it would be probability of greater than 62, correct? Yeah?
Yeah.
So it has to be greater than 62. It is somewhere here. All right? So it has to be greater than 62. Now, first thing you need to do is define. So here I've written there, let x, which is my CRV, in terms of his arrival time, his traveling time, is normally distributed. Mean of 55 and standard deviation of 5. And I will always draw the graph so that I know I'm looking at which tail. I'm looking at this tail.
Oh, arriving late.
62.
Come on.
So probability of x greater than 62 is 0.0808.
That's a stupid mistake from me. Again. Yep.
Okay.
Those Chinese people. Come. Ni hao. For a period of time, Mark always got out of bed at the same time, but finds that he tends to arrive late approximately 85% of the time. What time is he getting out? Bed to the nearest minute. Okay. So, actually, continue.
What IQ score would be considered like what are these students?
What's that
Right.
What is that? Upper bound for what? Infinity. Yeah.
Is it left or is it right?
All right. So the next question for period of time. Mark always get out of bed at the same time, but finds that he tends to arrive late approximately 85% of the time. What time is he getting out of bed? So what you need to think about is you have to draw the standard deviation. I always do that. This is one thing I do. This is the other thing I do. I always draw it so that I know that I'm looking at right or left tail, or right in the middle or whatever. So you know that here, from here, the chances of him being late is 85% of the time. So the area under the graph, which is a right tail, has to be 0.85. So therefore, you can work out that case about 49.82 minutes, which is approximately 15 minutes. So 15 minutes, work backwards from 9:10, which is 8:20. So this sort of question are the things that you are expected to know. Use the normal probability, use the normal distribution, and then work backwards. All right?
Yay.
So if you know how to use your calculator and if you know how to draw a standard deviation curve, it makes life so much easier.
Yeah.
All right? Because you know what the area is, left or right tail.
This is just plug and chug.
That's the important thing is know which
It's only
equation
two.
you're looking at.
I would
So
just
example
CDF
4.
or inverse CDF.
8,240 students in WA were given an IQ test. The score were normally distributed with a mean of 100 and a standard deviation of 16. Alright? So determine how many of the students to the nearest 10 achieve an IQ score of less than 93. What would the minimum or maximum score of the middle 60% of the student on this test? And what IQ score would be exceeded by a quarter of the
No,
students?
that's PDF.
So first thing you need to do is, of course, define. All right? Let X, which is the IQ score, is normally distributed with a mean of 100 and standard deviation of 16 square. All right, variance of 16 square. All right? Do that, and then sketch your normal distribution curve. So less than 93, less than is your left tail. Right? Here, the middle 16%. You need to think about the middle.
Right.
And then exceed by a quarter,
2000.
greater than 25%.
Times by, not divided by.
So if I draw it, I know that this is left
That's
tail.
all students on the same.
Yeah.
That should be right.
I mean,
think-
using your class pack, when you've got the X, if you're looking just at the CDF, you're using normal CDF, not inverse. So you can work out what that is. All right?
Sir,
Yeah?
do you have to do negative infinity because surely you can't have a negative IQ?
You can't have a negative IQ, but it just go on. It's just the way it goes. It's the graph inverse. So there's no negative IQ. I mean, well, I don't know what is the lowest IQ. There's no negative IQ. It's just the way it is drawn. That's all.
So you have to do negative infinity to
Yeah,
93.
yeah,
Okay, alright.
yeah. It doesn't matter. Even his IQ, you have to do that. Yep. There's no negative IQ because
No one.
no one. I don't know what his lowest IQ score is. All right. Or could be one lowest IQ score, but
Yeah.
who knows? All right. So if you do that, it has to be negative infinity to 93. So therefore, it's approximately 2730 students. All right. To the nearest 10. Again, something like this, you'll be caught up if you're not careful, if you don't read the
What
question
you get for the
carefully.
high and the low?
Those are the sort of things you need to know. Read the
I got
question
like
carefully.
86.5. So,
80.
And
Wait, Jules,
the
you
next one,
Jules, you did 0.4.
what I've done
Yeah,
is I
please.
drew it
It's 60.
and then I defined this as K.
60.
All right. 60%. In here, 60%. So here,
Yeah, but I did
the
it,
word here, the middle, 60%.
like from the left.
So if you look at that, the middle, 60%.
Yeah.
So you know that is, if this is middle,
You
that
center,
will be.
Huh?
What I'm
I
doing
just did
is
left
I'm
and right.
defining that distance as K.
Oh. Okay.
Isn't that the same thing?
no,
Right?
yeah, that would work.
But my numbers are completely different to them.
We'll make 80 wrong.
Wait, you got 86, yeah?
Yeah.
Go ahead.
All right. So you know that the area is 60%.
No, but
Did you get
I
86
might be
as well?
wrong. I will.
153.
So you need to see it's between 100 minus k and 100 plus k is 0.6. I define that distance as k.
Forgot about Stanford.
Rather than defining the two numbers a and b, because
Yeah, okay,
I
you're
know
cool, man.
this is a
You're
100,
No.
so I've got 100 plus
No, it
k
is
and
nice.
100
It
minus
is
k,
nice,
and
I don't
and
know how
that's,
mine
0.6.
works as well. Well, IQ score would be exceeded.
I mean, like I say, I would suggest that you use your stats, because if you use your stats, you can see the plot. So under stats, calc.
How do you do the last one?
Inverse, man.
But you don't know the probability. Oh, it's 75. isn't it?
It's
75.
not inverse, it's just normal. Yeah.
No, it is inverse.
Oh, yeah, it is inverse.
0.75.
So you should see that
100.
the minimum score is 86.53 and the maximum score is 113. So in terms of IQ,
89?
we really
110.
don't have a 87.5 IQ or 99.5 IQ sort of thing. So you should just give the answer as whole number if you say it's IQ.
It's right.
No, it's 110.
But it's left. It's right.
All right. Remember, interpret
Right,
the question
if
carefully.
you're doing it from right, it's 0.25.
You really need to
If you're doing
interpret
it
the
from left,
question.
it's 0.75.
You can't, in this situation, you can't give two decimal places because there's no half IQ. The IQ is always a whole number. All right?
I thought it was
Now,
exceeding a quarter.
once you know how to calculate it, you know how to draw that,
110?
you should be able to get your answer. And then what IQ score will be exceed by a quarter of this.
111 technically.
So it has to be greater than 0.25. Sketch it. So I know that it's this by a quarter of this student. So it's exceed 25%. So you can work out that approximately 111 is exceeded by a quarter. Alright? So exceed is greater, so you know that it's right tail. This bit here is 25%. Rather than that bit. Alright? I mean, if you work out that bit, it should be symmetrical, should be the same, but you are interpreting it incorrectly, so it has to be that.
Calm down, man.
Alright, last example, example 5.
So you have 2 more.
Example 5.
2 more examples.
2 more on this one.
So again, you need to let x. Here, you've got 3 decimal places. And the standard deviation is given to you 0.01. So I'll dim that for a while. Let you work on that first. Let you work on it first.
Sir, I can't see the question. I don't know the numbers. What was the question A? What's question? Axel, what's question A, bro? No, come on now.
What's the probability that the contents are less than 2 kilos?
Tom was just like, don't want to be okay.
You do the last one.
Yeah, I
don't know the question.
I don't. Bro, this is so. That one. It's binomial distribution.
What does that mean?
Remember we did DRB? So it's like, do you know what Bernoulli distribution is? So it's yes or no, right? So binomial is multiple Bernoullis in one. So 5 Bernoullis, so like 5 people. Yeah, so you just do binomial distribution. Remember binomial CDF? Interactive.
Wait, what's the second question?
Just read.
So-
CDF.
Such bags are randomly selected. What is the probability that
Then you just sub it in with the number.
will have contents?
I was a little bit
Trial
lazy
5.
here. I did actually sketch the
Probability success.
standard. I didn't really sketch the normal distribution graph. I should to make life a little bit easier, but sometimes when you're used to it, I
Say
know
what you
you
do.
get lazy.
Oh, 0.1, not 0.01.
So what is the probability that the content of a randomly selected chosen bag of these bananas has weight less than 2 kilograms? So less than 2
No, he did 0.1.
Yeah.
would,
It was me.
okay, it's 0.01 not 0.1.
Yeah.
So if it is less than 0.2, the probability is 0.0668. 4 decimal places as a minimum. So when you give probability, always 4 decimal places. Now, part B, if 5 bags are randomly selected, what is the probability that 3 or more will have content weighing less than 2 kilograms? So, see, you are tying this normal distribution to binomial distribution now. So what you're looking at is either greater than 2 kilograms or less than 2 kilograms binomial. So therefore, see the difference? What I've done is I have redefined this. Y is actually a binomial distribution, and the number of trial is 5, and the number of success is 0.0668. Yeah? So therefore, with this, you should be able to work out what your probability is. Again, use your class back.
It's 3 to
You
5.
really need to be able to use your
It
class
says
back
3 or more.
and able
So
to
3 to 5.
interpret the question from one to the other.
That's a toughie, mate.
5 bags.
So you've got normal distribution and then link to your binomial distribution. So you need to know number of trials in terms of binomial distribution and also the success rate. Therefore, writing all this is so important. N is normal distribution, that is binomial distribution.
Yeah.
All right?
Wait, how would you do that in your class bags?
Sorry? Okay.
Binomial. No,
Binomial. So, let me show you. There's a class.
No, it's CDF. CDF.
But I use PDF and I got the same question.
You minus 1.
Binomial PDF 3.
Is it PDF or CDF?
CDF.
CDF.
You always use cumulative
That's
CDF.
9. That's 2 6 or 2 7.
You always use CDF.
Yeah, but that's
So binomial, which one do you want?
I didn't use this.
I'm asking
Then do it.
is it binomial PDF?
CDF.
I think that's right.
Binomial, sorry. Binomial is PDF. This one will be binomial. Sorry.
But PDF or CDF? CDF. CDF.
Bin PDF.
PDF is for one value. One value.
It
It
is
says,
one value.
no, it says, what is the probability that 3 or more? 3 to 5.
Oh no, binomial is discrete, of course. Discrete.
Binomial PDF.
No. Hang on.
No, it's CDF. It is CDF.
Because it's less than 3, it's not exactly 3.
Because the inequality. Yeah.
So it's between
3 to 5.
Greater than 3 to 5. No choice, why?
Is this 7?
Probability of access is
Well, there's 6 questions. 7.
6.
I can try use PDF.
Alright, the other thing is, when you do this, alright, when you do your binomial PDF, I would actually just copy this and then just transfer it across.
Yeah, it's close enough.
Yeah.
Alright, use your ClassPad capability, copy this and transfer it across, rather than just use 0.0068. If you're not sure, let's do it together.
What's the next question? Can you show me the next
Do you want me to do it with you on the
Next
ClassPad?
question. Oh, this one.
question? Yeah, 6.
Yeah?
Right, it's easy.
If you want me to do it with you on the ClassPad, I will be happy to. If not,
Give me what?
I assume that all of you know how to do it.
It's probability
Yeah?
of this given.
Alright, last question.
Oh, yeah.
Last question.
Yeah, it is given.
Yeah,
So now this one you got to think about
Because it's given
Uh,
that.
yeah.
probability, which includes something given, which is a conditional probability. The Fisheries Department of Western Australia places a minimum size of 127 millimeter on crabs that can be taken by amateur fishermen. It is known that the size of crabs in a particular estuary is normally distributed with a mean of 129 millimeters with a standard deviation of 16 millimeters. Determine the probability that a crab of legal size caught by a fisherman is larger than 160 millimeters. So you must know
0.04.
the legal size is greater than 127, right? The legal size is greater than 127. Now you want to know that the probability of the crab larger than 160 millimeters. You know that the person has caught a legal size crab. So now what I do is I will let X, which is the size of the crab caught, as normally distributed with a mean of 129 millimeters and the standard deviation of 60 millimeters. Always write it down. Always define your distribution. Then you know what to do. You're given that the crab caught is actually legal. So it has to be greater than 127. Right? Given that it's 127. And what is the probability that it's actually 160 millimeters? Greater than 160 millimeters. So you've got conditional probability now. You've got to think about what are the conditions. How do you find the probability?
0.0.
You've got two sets of
0.79.
probability here.
Yay, I got it
Alright? One. If you draw it, this is 129. Alright? So legally,
Patient.
this is 137. This is legal size.
You said that.
Yeah? And then
Are you gonna
160 is somewhere here. 160 is somewhere here. Alright? So you know that it's this bit
pay $60,000
over that bit.
for 50?
Little bit here greater than 160 over greater than 170. So you could write it down that way. Probability of x greater than 160 over probability of x greater than 127. Use your ClassPad. Alright, I'll show you what to do with ClassPad in this case. I'll show you what to do with ClassPad in this case. It's pretty, I would use a fraction.
Are you gonna enroll for the taxation?
Alright. If you go to your ClassPad,
$60,000 for a year. 60. Yeah, starting salary of 60,000.
go to your ClassPad, mate.
Superannuation, but it includes.
Make sure that you clear everything. Clear all variables and clear
Not
all.
psychopath, so.
Yeah.
So if you go to
Well,
keyboard,
you can't even go to uni.
go to your
Oh, exactly.
go to your
It's gotta work.
That's so bad.
Unless you want to work.
fraction. You want it to be in fraction rather than one divide than the other. So under interactive, I go to distribution, continuous, normal CDF. So the lower bound for the numerator is 160,
What's the next question?
and
I don't know how to
upper bound
Oh,
is infinity. And you know that the standard deviation is whatever it is, 16. And then the mean is 129. All right? So when you do this, when you click OK, it will come out in invalid syntax because it does not have a denominator yet. You have to do the same thing with the denominator, but instead of going through that process, I will just highlight the numerator, and drag it down,
So
and change that to 127.
The amount of so it's 1 is the first.
Do you put in the variance or
Yeah.
the second variance?
Negative
Yep.
is 2.
So it's 16, which is the whatever you call it, the standard deviation as a mean. And then when you tap execute, you get the number. All right. If you want the individual one, you can highlight that and drag it,
No,
and
it's
you get the
'cause
individual
you have
number.
to use the normal.
All right. It's up to you how you want to do it.
So it's 0.52.
I like it this way, although you got to make sure that the step it says that it's invalid syntax. Ignore that, and then put in the
55, right? You got 55.
put in your
So you have to-
denominator.
So if you use the normal, it gives you how
Alright.
many?
Does that sound
So
good?
therefore,
That's
you
it's
get an answer
0.524 of the first
0.4791
deviation.
75824,
Oh,
and it's approximately 0.479.
Yeah. Yeah, that's what I do.
This bit of it is a lot of calculator usage. Once you know how to use your
Gives you how
calculator,
many
it's
deviations it
pretty
is across.
straightforward.
So it's 0.5497.
So I'm going to stop here. I will. I've uploaded
So there's
some
one more
exercises
question.
for you to do.
There's one more question.
Oh, okay. Determine the probability. Okay. Cut by efficiency.
No, on the next slide.
Okay, let's have a look. Sorry. I thought that's it. No. Now, the continuous random
Mean
variable
of
x
one.
is normally distributed with probability of x less than 55 to 0.7.
Yeah, so that's if it's
Alright.
a normal one. If it's a
So,
normal
how do we answer a question like this?
Oh, it's so wrong.
You
How
look at the
many
normal
standard
graph.
deviation from the mean is a score of 55?
It's 0.5.
Here, you need to use a standard score.
Oh, no.
No. So it's 0.75.
Because you're only given this
You know it's gonna be more
information.
than
You
that.
don't know what the mean
It's
is.
going to be here somewhere.
So you got to transfer everything to
Isn't the
the
mean
standard
of 1?
score.
So wouldn't the
Alright?
mean be
Now here,
1 there? So how is 0.5?
you see that
Because
anything
it's
that's below 55
deviations away.
is 0.7.
It's half a deviation.
You have absolutely no
It's that
idea
many
what the
deviations
mean
away
is.
from the mean
But
point.
with the standard score,
It has to be to the right. 'cause
I know that
it's
standard score this is 1,
it's
correct?
5, is it? So you're
Yeah?
half-
Right, sorry, this is 0.
It's not exactly.
Standard
half,
score is 0.
Yeah.
So anything
5
above that, if you could work out the distance
mean
from
of
the
0.
0, you would know how many standard deviation it is from. So have to use the standard score.
Yeah, deviation is 1 minus.
Yeah, I thought
Standard
it was
deviation
1,
is
so I
1.
was like, fuck.
So you know that probability of, in this case, this would be A for the standard score, is 0.7. All right? So therefore, A is 0.5244, and A is 0. So therefore, 55 is 0.5244. Standard deviation above the mean. Now, you must use the word above the mean. All right?
Yeah.
So what I've done here in this question is actually use the standard score, because I have no idea what the mean is.
So
If I know what the mean is, then I can work it out. Yep.
if you had like something less, like negative 0.5244 standard deviations, would you say it's negative
Mean
0.5244 below the mean, or you just say
I
0.5244 below the mean?
0.5244 sigma below the mean.
Then get rid of the
You
negative.
get rid of the negative.
Okay, cool.
So because above is positive, below is negative, you don't have to do double negative.
Yep.
All right?
Mean life should be 1 over.
So the next bit, if the standard deviation of x is 4, find the mean of the distribution, giving your answer correct to 1 decimal place. So, you now need to find the mean of the continuous random variable x. Alright, you know this is 0.5244 sigma.
Learning task though.
Alright,
Yeah.
so
It was zero
4
yesterday. I've already done it.
standard deviation of x is 4.
It was
Too
a-
good, bro. Was it easy?
Use this.
Yeah, I just did
Z,
the
the Z score is equal to x minus
Because
Uh,
our friends didn't teach them, so the tests were easy.
mean divided by standard deviation. Alright? Z score of 55 is 0.5244. Alright? That is 55. The x is 55. Take away the mean, which is here mu, divided by 4. Alright? And therefore you can work out the mean is 52.90 and 1 decimal place should be 0.9. My fault.
That's not even all the questions.
I didn't read the question carefully.
Wait, so
Except for 2020.
Yeah.
Then cut through 2019.
So you know that 55
Yeah.
using your idea of standard using your idea of standard score, you know that anything that's below 0.7 will be you anything below 0.57 you can work out how many standard deviation away is from the mean. Alright? Because a standard, if you've got a standard normal distribution, you know that this is always 0.
Yeah.
And then this
Deviation
is
1.
1 sigma, 2 sigma, and so on and so forth. So if you know the probability of here, somewhere here, is 70% or 0.7, you could work out the equivalent.
Yeah.
Yeah? Equivalent standard deviation. Alright, this is last question. Stop here. Lots of questions for you to do.
Okay.